Welcome back, folks. Episode 48 of the Get a Grip on Lighting podcast. Man, we're almost at 50, son. That's right. I bet you all listen to every single show, don't you? A couple times? Come on, man. Episode 48. Guess what? On today's show, we have Dr. Matthew Ma. Man, he knows a lot about bypass LED tubes. Holy mackerel, Greg.
Yeah, LED tubes in general, and something that what I really like is YouTube videos that he puts out there. He's had a lot over the years that really demonstrate different things that they've got going on, which is cool to see, and issues in the lighting industry.
He really, it's interesting because I read this thing where everything is history, right? So this is basically, this episode is like the history of LED tubes.
Exactly. Yep.
Like how did who were the first ones? What were the problems and the improvements and all that sort of stuff? And now we're still improving, actually, as it happens. It's still going. This episode of the podcast is brought to you by Aleddra. Aleddra.com. That's Aleddra.com. Greg, tell us a little bit about Aleddra.
So in relating to the podcast topic that we had was the origin of the LED tubes, how they started, where they're at, how they've advanced. And really what Aleddra does, and I alluded to in that YouTube video, is they take head on any issues that people have. So the issues with a lot of LED tubes are, at first was the bypass ballast was a problem because of safety concerns. So Aleddra believes strongly that bypassing the ballast is the way to go, is the way of the future, and I believe that as well. But what they've done is addressed any safety issues. So you can see on the website that Matt has pulled up here, they have the G5 SureFit DBA LED tube. So what that does is it can work off a ballast, and it can be single or double-ended wired, meaning you don't have to change the sockets. The other additional feature they have, and I've got a demo here, Matt, if you want to go back to me, is here's just a keychain of the LED tube. They actually have a safety switch on the ends so that you need to engage those for the lamp to work. And why that's an issue is because they talked about the safety of somebody installing it, holding one end while they're installing the other. Current will run right through, and that'll be a shock hazard. They actually address that issue that a lot of the companies that didn't do Type B had, and they make it safe install. And they're the only ones in the market that I see that has something like this.
It's interesting that that's becoming safety, and I like the way this industry is going in terms of continually kind of get to. There's going to be a point I think we're going to get to where like this is how LED tubes should be made, though. That's got to come soon. That's not 20 years away.
No, I think it's going to be one set way, and everybody's going to have to follow.
Standardize it. That's it. This is it. Now maybe you can play with wattage like they do with the low watt fluorescents and all that, but it's got to be this long. It has to work this way. And that's enough. So it's time for that to get some NEMA standardization on that. But anyway, listen to Dr. Ma, man. If you're interested in LED tubes, if you're a lighting dork, a lighting geek, this episode is for you, man. Episode 48 of the Get a Grip on Lighting podcast. Welcome to the Get a Grip on Lighting podcast, Dr. Ma.
Thank you. It's my pleasure.
Say hi to Greg Garrick.
Hi, Greg.
Hi, good to see you again. It's been about 2 weeks now, but now we're on film.
That's about right.
Yeah.
Thank you.
Very good. Mm-hmm.
So before we get into your some of the stuff about LED tubes, which I think it probably interests the two of us the most, tell us a little bit about your 9 patents and sort of your background in the industry, Dr. Ma.
Sure. I'm working with Aleddra Led Lighting. I personally hold a PhD in EE from Michigan State University. Since joining the company 6 years ago, I have filed and received 9 patents, all related to LED technology. And the company as a whole has today 35 patents, out of which 25 of those patents are related to LED tube technology. So it is fair to say we have the most depth in terms of LED tube technology. And then the LED TA that we're selling today is Generation 5, and the Generation 6 is coming. And there's still the Generation 7 in the pipeline. So we keep pushing the envelope on the LED TA tube technology.
Tell me a little bit about your relationship with your partners in China. Or is it the same? Is it a corporate relationship in that you own a factory in China, or do you guys are you guys private labeling your stuff under a contract situation?
We own our own factory, and we develop our own technology. So we have our own factory make to our design. And on occasion, when we have a large need of boosting up our production capacity, we may find some partner that will make to our spec. We have our own factories, and in need, we will use some third party to produce our own lamp.
Very good. And what I really love about what you do personally are your videos online, your YouTube videos, tackling head on some issues that people talk about or hint at, but really nobody puts out there in full effect like you do. And you have those YouTube videos where you actually install fluorescent tubes on a fixture that's been bypassed and things like that. And that's what I appreciate you doing that. So thank you.
Thank you, Greg.
Yeah. So what we really wanted to kind of
so if somebody listening to this right now is on their phone and they have their headset on and they want to watch some of these videos right now, go to youtube.com and type in Aleddra LED.
Yep.
And you guys, your channel will come up right away?
Right, with one L and two Ds, Aleddra.
Aleddra LED. Look, if Greg Eric's watching them, I checked it out too. If we're watching it, guys, it's worth it. It's nice to see those fluorescent tubes put on those sockets. I'm not going to be a spoiler alert here, but Greg, take it on from here. What's going on? What do you want to ask Dr. Ma?
Yeah, so we had a nice conversation. He was actually in my office, and then we kind of did the podcast there. But I said we need to record this, and what it comes down to is a white paper that you actually wrote about the evolution of the LED tube. So what I really would like is for you to break that down for the audience and start from the beginning, and we'll dive in from there.
Most definitely. We got into the LED tube business about 6 years ago, and the first initial introduction of LED tube to the market was about 8-9 years ago. Since then has changed a lot, and the design and the issue that different LED tube causes and force the manufacturer to come to a solution to the problem that has been identified. So I walked the audience through the history of LED tubular lamp development, so you can see what is the problem, how one generation of the tube technologies try to solve it, but without bringing its own problem. So back in the days when it first introduced, just looking at a fluorescent TA fixture where you have the ballast. And the reason that you have the ballast is to activate, number one, raise the voltage to 300, maybe 600 volt. With that high voltage, then you can activate the plasma inside of the fluorescent tube. So you will light up. So ballast is required to light the fluorescent tube. So when the LED tube first introduced, people think, okay, well, LED tube has its own driver, and the driver converts AC to DC, and really there's no need for the ballast at all. So the easiest way to do is really just to bypass the ballast. And given that the ballast output has hot on one side of the fixture and neutral on the other, if they simply bypass the ballast, leave the wiring of the fixture intact, that is hot on one side, neutral on the other, and off you go. That would be the easiest way.
Sounds good to me.
Yeah.
No. Who came out with the first LED tube? Do you know?
I don't know. I would say about the same period of time, a large number of consumers, especially the manufacturers of consumer electronics from China, manufacturers, jump onto the LED bandwagon because the lumen accuracy is hitting 80, 90 lumens per watt, become viable for general utility lighting.
No, hang on. See, your article stated that double-ended was the first LED tube, but I remember single-ended bypass being the first. Don't you, Greg? Do you remember that the same way?
I feel like it was double-ended and Type A. I don't know which one came first, the one that worked off the ballast or not. But
so actually, it is a double-end Type B. Actually, the Type B has Type A is ballast compatible. Type B is ballast bypass. With ballast bypass, you can wire single end or double end. So the reason the Type B double end came first because that's the easiest way to do it. You don't have to rewiring the hot neutral all to one socket and replace the socket from shunted to non-shunted socket. That's required for single end. Right. So people start with the easiest route, which is the Type B double N. But shortly after the introduction, UL, the safety body, they did some tests and identify the Type B double N LD tube has a liability. That is, if someone are replacing those Type B double N LDTA without turning off the power, if someone say this is a bypass double N wire fixtures, if the power is on one side, if you put the tube in, and before you insert the other end into the socket, you touch the bipin by accident, you will get shock. So there is shock hazard as identified by UL. So in their new 1598C safety standard that govern the tube retrofit, it added a new mandatory clause from the 1598B to 1598C. That is a mandatory anti-shock protection. So it is now required, well, since then, before that, 1598B didn't address that, but when they identified there's an issue and serious issue on the electric shock, in their 1598C requirement, they added this mandatory anti-shock protection. Given that most of the double N LDTA does not have anti-shock protection, that UL safety requirement literally wipe out most, but not all, of the double N TA from the market, because no one would want to buy a non-UL product, except some manufacturers back then identify a loophole in ETL's TA safety standard. ETL is another safety standard body similar to UL, but not as widely adapted. For their TA safety requirement are very similar, except one critical component. The ETL TA safety requirement does not mandate an anti-shock protection text. So some of the manufacturers went through that loophole, get their double N ETL certified, even though that those tubes would still have the shock hazard that cannot be UL certified. So that's generation one. With the UL 1598C mandatory anti-shock, double N type B, if you don't have anti-shock protection, you can no longer be UL certified. So the manufacturer move on to single N, type B single N. Compared to type B double N, to retrofit a single NTA, you add extra labor. You have to rewire hot and neutral out from to one side of socket, and more than that, you will have to replace the socket from shunted socket to non-shunted socket, so that both bipin, one will connect to hot and one connect to neutral on one socket. If you are using a shunted socket, the metal plate inside already shorted, so it cannot be used to power a single N LDTA. That rewiring and replacement of the socket, especially in the fixture in mid-air, more than double the installation cost. So in the right mind, unless there's without the mandatory anti-shock protection, people will go with double N wire because there's no need to replace the socket. Now, because of that, they were forced to move away from TA, double N TA that doesn't have the shock protection to single N TA.
So do you have any issues? Yeah, for sure. Do you have any issues with single-ended T8?
Of course, that's why there's continued involvement. So when you move from generation 1 type B double N to generation 2 type B single N, there's some, most of folks didn't realize the big three lighting manufacturers, the Philips, the Sylvania, and the Cree, never make or sell single N LDTA. And there's a reason behind that, a serious reason. Because when you retrofit the strip fixtures to single end. Down the road, when the LDTA, the single NTA dies, a custodian takes it out and replace, not paying attention to the fact the fixture had been retrofitted and shouldn't use fluorescent tube. He just insert just like he always do, put a fluorescent TA into a single end wire fixtures. Guess what will happen? You have hot and neutral all come from one socket, and the bipin of the fluorescent TA are actually connected internally. So once you put those bipins of fluorescent TA into this non-shunted socket with hot and neutral, you complete a loop. Boom, it short out.
I'll tell you, it's even worse. It's even worse in Ontario, because in Ontario they have single-ended bypass 347 volt LED tubes.
Yes. Yeah.
So you're tripling the voltage to a small non-shunted T8 socket. If you put an LED tube on that, you're going to have if you put a regular fluorescent tube on that or a non-bypass LED tube on that, you're going to have a big short circuit on that sucker. And there's thousands and thousands of those sockets out there in Ontario right now.
So what exactly, what will happen on 120, on 277, and on 347? Does it depend on the fixture, or is it every fixture the same result will occur?
It depends on the voltage and the construction of the fluorescent tube. Some of the fluorescent tube has very well built and strong glass. So at 110 or even 277, you would just short it out, fries it, and you see some flashing, but it doesn't break. I have not tested on 347, but I have tested some of the lesser quality, very thin glass fluorescent tube. It will fragment fractures even at 110.
Yes.
So even it doesn't explode, but after the showing out, you can see, especially for those that has been used for a while, you can see that it's broken down, and you can just squeeze it, it fractures.
Yes.
So I would not test on 277 volt because my insurance doesn't cover that. So that's generation 2. And of course, back in generation 1 and 2, the big 3 lighting company couldn't find a solution that is safe enough that they can put their name on. So out comes the generation 3, that is the Ballast compatible tube. And they all came out and make the claim they are the first to market. Well, in fact, back 3, 5, 6 years ago, there's another not so well-known company already promote the Ballast compatible type A tube, but nobody pay attention to that because why do you want to keep the ballast in the system when the LDTA really have no need for it? But well, some company find a way to persuade the customer, the end user, and the utility company that is the safest way. With type A ballast compatible LD2, the promise is you can just simply plug and play into existing fixtures. If you work off the existing ballast just like that without doing any rewiring. So that was the promise, plug and play. But the reality is more like plug and pray. You pray that you have a compatible ballast. If you don't, you got stuck. You have to buy a new ballast that is compatible in order to work with the ballast compatible LDTA. When the first iteration of ballast compatible LDTA type A tube come about, the ballast compatibility is about 60%. Right now, it has improved quite a bit to 80% with electronic ballast, but there's still the magnetic ballast, the program style ballast, the rapid start ballast, and if for newer facility, you probably have electronic ballast, most of them. So even
but you also have dimming systems. You also have dimming systems and lighting control systems as well.
Good question. Exactly. Dimming at another parameters, and especially the dimming control for 110 and 277 volt are totally different. So with type A tube, yes, it will work if you have a compatible electronic ballast, instant start ballast, but The ballast compatibility, just one of the 5 issues with the ballast compatible tube. So number 1 issue is, of course, the ballast compatibility. Hopefully you have a compatible ballast in your facility. Issue number 2 is ballast dependency. Ballast compatible tube cannot operate without ballast. So ballast, when ballast die, you have to go out and buy new ballast, put it in. That's your cost on material and labor. Issue number 3 is additional energy draw. Ballast usually drop anywhere from 4 to 6 watt. Depends on how many lamps is powering. Back in the days when you have 32 watt fluorescent TA, that 2 to 3 watt per lamp energy draw is no big deal. But with LED TA, the wattage has dropped down to 15. We're seeing the trend down to 12. The additional 2 to 3 watt draw is 20%. So why you want to leave that 20% energy draw in your system when you don't have to? So that's issue number 3. Issue number 4, a lot of folks learn that the hard way. That is, when you have the ballast in your fixtures, there's always the potential of arcing. I have a fluorescent tube here with a ballast fixture right here. I'll show you what I meant by arcing if you haven't run into. So now it's leading. Okay, so now right before the bipin touched the metal end cap, try to. Do you see this flashing?
Sure.
Do you see some of the noisy?
We can hear it, yeah.
Do you hear it? Okay. Yep. So right before the bipin touched the metal plate inside the socket, because the ballast raised the voltage above 300 volt, most likely 600 volt, there's a flag jumping from the bipin to the metal plate right before it makes permanent contact. That flash creates heat. And over time, it could melt the socket or the end cap. That could happen with the fluorescent TA as well, with a loose socket, especially old fixture with a loose socket, that can happen. But usually it won't damage the fluorescent TA because it has glass housing and metal end cap. It doesn't do much to damage it. But most of the LED TA has plastic end cap. So there are a lot of reported instances where the LED TA, because of arcing, cause fire, get burned down.
Yeah, I've had several hundred LED T8s come back that are ballast compatible with arcing that have failed, and there's evidence of arcing at the end of the tube. Yes, and so that causes more damage to LED tubes than it does to fluorescent tubes.
Right. For that reason, Cree, one of the big 3 lighting company, have 2 recall of their LED TA, the Type A TA, 2 recalls, and eventually exit out of the market completely because they just couldn't find a way to solve that problem satisfactorily. If a leading company couldn't do it right, and if you believe all other lesser quality company can do it right, you're having great faith on
Dr. Ma, you know what's interesting? I've been in this business for the LED. I've been in the business for 18, 19, 20 years. And I've never had one guy come in my shop and say, you know what? I got the crappy LEDs, dude. I got the ones that are going to burn out. I've had so many people come in my shop and say, why are you dealing with that guy? Why are you doing this guy? We're the bad. I think the reality is that most people, nobody really knows actually who's got the best stuff.
Exactly. So arcing and burn hazard is issue number 4 with Type A tube. Issue number 5 with Type A tube is the delamping incompatibility. What I mean by delamping is when you do TA retrofit, sometimes because LED TA is so bright, you can reduce the lamp, number of lamp in the fixture, so dropping from 4 lamp to 3 lamp, even to 2 lamp. That's called delamping. When you do it with Type A tube, remember the ballast in the fixtures is a dump device. if a say a ballast is supposed to
But
power
won't
two
it just drive it at a higher ballast factor?
You wish. You can test it by the energy draw on single lamp or two lamp. So say you have a 2-lamp ballast and then 2-lamp fixtures with a 32-watt LED fluorescent tube, you should draw 64 watts, right?
Sure.
So if you remove one, so 32 times 2, 64. If you remove one fluorescent tube, say for a natural energy saving, easy way to do it, just remove one fluorescent tube, you will assume you would draw 32 watt, right? Well, the actual reading will be more like 36. Why? Because that dump ballast is still powering full 6 watt, and that load, the load you were supposed to serve supply 2 fluorescent TA, now all being powered into single, sorry, not TA, fluorescent TA. So the single fluorescent TA receive all the power. With fluorescent TA, there's no electronic inside, so it doesn't do any harm. But if you are doing that with the type A LED TA, when you have 2 lamps, each share 50% of the load from the ballast, that's fine. But when you remove one D lamp, that single LED TA is taking 100% of the load from a 2-lamp ballast supposed to drive 2 lamps. With the driver that's inside the type A LED TA, if you don't use quality products, good quality resistor, capacitor, that would hurt. One extreme case I learned in one of the universities, they retrofit a 2-foot LDTA on a 10-year warranty from the manufacturers. After 3 weeks, of installation, 1/3 of those 2-foot LDTA dies. It just dies. 10-year warranty, it won't last 3 weeks. Happen in the area, stop by, take a look. All the central, they D-lamp from 4-lamp to 3-lamp, all the central one die. Worse yet, the manufacturer couldn't explain why it dies.
So only one lamp out of the 3 in the fixture were failed, and it was the center lamp.
They're using 2 ballasts.
Okay.
So 2 of the TA is powered by 1 ballast, and there's 1 TA powered by the 2-lamp ballast. So that's the one that always get killed and strike out. But it doesn't happen on all type A tube. If they use quality driver component, it should withstand. It will last longer, but not as long as you would using 2-lamp, of course. So that's issue number 5 with type A tube.
There is a lot of fixtures out there in Ontario that are 1-lamp fixtures but have 2-lamp ballasts in them, driving 1 lamp. There are lots
it would definitely
of
shorten.
like
that. If they do that with the type A tube, chances are they will shorten the life of that LDTA, the type A LDTA.
Wow.
Yeah.
So where are we now, Dr. Ma? Where are we now? Where should we be, and where are we now?
Okay, well, with type generation 3, there's still the issue. Guess what? The company that promote type A the most are the company that will want to sell you the ballast. So you want to use a ballast, a new ballast with a new ballast compatible tube. If I'm making and selling ballast, I would do the same, except we don't. So and many manufacturers don't sell ballast as well. So they come out with a solution to address the issue with the type A tube. That is a dual mode tube. A dual mode LDTA will work with ballast, compatible ballast that is, and line voltage. The reason the dual mode tube come to the market is because if you run into incompatible ballast, if you don't want to have additional energy draw, then you can move from ballast compatible mode to line voltage mode. So with the dual mode tube, obviously, when you have an incompatible ballast, you can just cut the ballast, straight to line voltage, off you go. The reason it is handy to some facility is because they don't have sufficient many electrician on staff, say school district, only a few electricians have to support 20 different schools, they can use dual mode tube to have the custodian plug and play, if they have compatible ballast, into their facility over the weekend or overnight. During the screw break, they can then have the electrician come in, bypass the ballast one by one, and then reduce their energy consumption further. So that's the benefit of dual mode tube. However, there are different design of dual mode tube. With the proper design, it will solve all the problems. It will be shock free, arcing free, and true to its word that is ballast compatible and line motor driven. But most of those dual mode tube on the market, if they don't design properly, they actually inherit all the issues from the previous 3 generations.
So
if they
one question quick on this dual mode I want to get into is so I assume that if they're going to work type A and type B, they must have an internal driver in there. And does that internal driver not get utilized at all when it's on a ballast? And then when it's cut from the ballast, it all of a sudden kicks in. So does that increase the life of a tube?
There are two type of driver design with the ballast with the dual mode tube. Some actually use 2 different drivers, and with a circuitry detecting whether the input is from a ballast or line voltage. So they kind of switch between. So it literally has 2 drivers. Some dual mode driver share a large portion of their circuitry. So some component, so it saves some material cost than having 2 drivers. So it depends on the internal design. But again,
so if they
back
have
to the same question. Go ahead.
Would it be if they have 2 drivers? Then would it last longer if they utilize the ballast for a couple of years, and then when they cut the ballast, they get it's like having a brand new. I guess you have the L70 though. You're losing light, but wouldn't it last longer doing it that way? Because that
depending on the
driver hasn't been
design,
used.
yeah. Depending on the design, you actually add additional cost to the material because
but what Greg's saying, I think what I hear Greg saying, if you're making a sales pitch to a customer, you say, look, use your existing ballast for now, and it's almost like a free driver change after 3 or 4 years when the ballast burns out. That's what you're saying, right, Greg?
Yes.
You're thinking sales rep. You're thinking I'm going to pitch this into my sale.
Surprisingly, I actually try to sell light bulbs every day. Yeah.
Is that right? Holy macaroni!
Weird.
That's a valid argument, except you are depending on the driver and design and overall lamp design is safe enough. If it's not designed properly, some of the dual mode tube operate double end on line voltage. Some of them operate single end on line voltage. Say they operate single end on line voltage, you will be inheriting the single end issue should a custodian reinsert a fluorescent tube back to that fixtures. If you're wiring double end on line voltage, if you don't have the anti-shock protection, then you're reintroducing the shock hazard to the fixtures. And
people should turn the power off when they change the light bulbs. Come on, man.
Oh, I totally agree. And guess what? They just don't. And it's not the electrician get himself into trouble. If they do get shocked, shame on them. They should know better. It's the smart custodian. We know how smart they are. When they do the change out, the reason they would.
But you can shock yourself with fluorescent tubes too. It's not an LED issue. Yeah. Like that's not a new issue. Like I'd like to clarify that for the listeners. So if you, especially high output, so if you go into a high output fixture and let's say it's got a spring loaded socket at one end, Greg, and you go to push that socket in and you decide to put your finger on the recessed double contact base when you push it in, you're going to get shocked, dude. And it's not 120 because the secondary voltage of the ballast, like Dr. Moss said, is 300 to 600 volts. So that's not particularly an LED issue, Dr. Ma. It's a relamping training to teach people how to change light. Don't touch the other end of the bulb, dumbass. I mean, I hate to put it that way. But the thing is, Dr. Ma, with the vast majority of LED tubes, you're not talking about slimline or recessed double contact. You're talking about bipin. So it's a lot less likely that someone's going to get shocked because they actually have to twist the bulb on a bipin
Correct.
bulb.
Right.
So the shock hazard is not as big a deal as perhaps people are making out. It was that way with fluorescent, and it's something you have to twist into the socket. It's a different issue with the slim lines and the HOs. That's a real issue. You can get
That's
blown off
valid,
ladders,
yeah.
but yeah.
That's definitely a valid statement. But when you will come out with the anti-shock protection clause, they want to have something that is dumb-proof, right? Foolproof. So when they regulate things, they want to make sure even people make mistakes, they still
Listen. The reality is UL, DLC, ETL, JAGA, all these compliance organizations, okay,
right?
are following the innovation. They're following it. They're not in front of any of this stuff. And they're allowing this stuff to go on the market with their label before they know what the true risks of it are. And I think that's a failure of their mandate, to be honest with you. In my opinion, if they're like all of these compliance organizations. Another one, Dr. Ma, and I know you probably have lots to talk about, but what about flicker? What about LED flicker? Have you got into much of that with the LED tubes? I know that it's not an issue with the Type A ballast compatible, and it has been an issue with the bypass being direct line voltage AC. How pervasive is the flicker issue with the existing generations of LED tubes?
I'm surprised that issue resurfaced. That was an issue talked about 4 or 5 years ago, and since then, I haven't heard for a while till recently. And there's a few company kind of kicking the dead horse, say they are the first one that's flicker free, and it's like, what? I heard that 5 years ago, and there's not an issue with the R tube since then. It's on the driver design. In the driver design, so.
I'll tell you right now,
design,
I would say the vast majority of bypass LED tubes in the market are not flicker free. They are flickering like crazy. I mean, all the ones I see out there in the field, you can do it with a camera on a tube. You can do it in different ways. There's a lot of flicker issues.
It's very easy to detect it using a camera. You can see that flickering through the camera lens.
And how was this missed by the industry? Like, because flickering is a major health issue, Dr. Ma.
Oh yeah, it was actually back in the days when the fluorescent tube was first introduced. People are so scared to use fluorescent tube with the ballast. They're afraid that it would burn down the houses. But that was 80 years ago. Then there was the flickering issue with the fluorescent tube as well. 60 years ago. They were cycling. They have that flickering cycle. Is not noticeable to most people, but has that flickering cycling about 60 hertz, and that caused the fatigue of the worker working under that light.
And we're re-causing it with LEDs, though, Dr. Ma.
Yeah. So again, to my knowledge, that has been solved a long time ago, and I'm surprised there are so many out there now having an issue. But it's a very easy way to identify just using camera. And
Greg, can I ask you?
One
second, Dr. Ma. Wouldn't you say that the vast majority of bypass LED tubes in the past were not flicker free?
That's what I would say, based on the previous podcast we had, and then looking into it. It looked like a lot of the LED tubes out there were flickering and are flickering in the Type B format.
It's an ongoing issue, Dr. Ma.
Okay, I'll take that. Thank you.
So now you got 6. Dr. Ma, there's 6 now. You need to use your other hand. Flicker.
No, we're at... Oh,
Flicker.
6, yeah.
Flicker.
Yeah, flicker. Thank you. So with the Generation 4 Dumo tube, some are safe, some are not safe, depending on the proper design. They are technology. Here's one example to prevent shocking. There are 2 different types of shock protection mechanism. One is mechanical. Here's one example. There's a mechanical safety switch on the end cap. there are several designs that appear to market, to my knowledge, maybe 4 or 5. This is one of them. The way it works is there's spring-loaded contact inside. So before the switch is pressed, it's not making any contact. So only when the ring socket got pressed, it's making contact, and only when both switches are pressed at the same time, it activates the lamp. That's one example. Another example is using a electronic detecting circuitry without using the mechanical switch. We call it electronic switch internally, so you don't see those things sticking out. But that depends on also how well that smart circuit is designed. With the circuitry, if you have loose socket making non-permanent contact on and off, those minor strike will probably cause some harm to those smart circuitry trying to detecting the shocking hazard. So that happens sometimes. But there are ways to make it safe, shock-free, dual mode, or single, or even type B, double N, with proper protection that solve the anti-shock issue. And there also technology that can prevent arcing, the arc-free tube. There are actually 2 types of arc. Go ahead.
Yeah, I was going to ask, are all UL listed Type B double-ended tubes right now have an anti-shock safety hazard or whatever device in it, built into it right now?
I cannot say that because they find way to kind of go around it. A little bit more on the UL with their Type B 1598C, that is the IFAR category. The safety standard mandated anti-shock requirement. So if you just submit a Type B double N tube, you will be subject to that shock test, electric shock test. But if you apply your dual mode tube under the battery, low bound battery for this computer. Hold on, I need to plug this in, otherwise it would die on me. All right. Here we go. Okay.
Good to go?
Good to go. But the Type A category, OLV, would accept dual mode submission, but it does not test electric shock on line voltage. So a lot of the dual mode tube on the market with OLV designation have shock hazard. Not all. A lot do.
So how is one to know?
Try it. No, actually, this is what I would ask. Ask their sales guys to do it for you. Don't do it yourself.
Sure. I would say ask their sales guys if they know what you're talking about. That would be the first thing.
Well, there's a one actually. If they would do what I'm doing right now with our tube that has a safety shock, I'm doing this, no shocking. This is what I call dare you touch test. So ask the sales guy of those dual mode tube, dare you test it. If they touch it, no issue, then it's safe. If not, think twice whether you want to buy that tube. That they will not even touch it.
Okay.
So we're in generation 4 right now with the dual mode. And is there going to be a generation 5? And if so, what will it be?
I would say they will be an improved and safe version of generation 4. It will be dual mode. But 20 years from now, there won't be any dual mode, it will only Type B. But even the tube can operate both with ballast and line voltage. 20 years from now, nobody will buy and sell ballast, especially when the rebate is going away and nobody have any incentive to keep the ballast in their system. So it's a matter of time that ballast all disappear. But it will take some time, especially with companies still promoting selling ballast to the end users. So
How
generation
efficient?
4. Go ahead.
How efficient can an LED tube? Right now, they're getting in the 160 range on a Type B. I've seen 150 to 160. So how much more efficient do you think it can get?
You'll be another 3 years, or you'll be less than that to hit 200 lumen per watt. That's the diode. Actually, some of the diode already hit that. And then when you add it inside of a lamp, that is called a lamp lumen output, it takes away about 15 to 20% off. So with 160 lumen per watt diode, you'll be seeing 135 to 140 lumen per watt on the lamp. When you put it inside of fixtures, the total fixture lumen output would drop to another 10, 15% to 120-ish. In terms of overall trend, I haven't seen the ceiling yet on the efficacy, so it'll be continue improving, but not as fast as we have experienced in the last 4 years. But it will continue pushing the envelope. So you are seeing now with the 4-foot tube, 15 watt is the predominant wattage for the AIDTA. You are seeing some of the 12 watts, some even 10 watts coming out, especially in the area where some of the utility mandate certain energy saving threshold. In order to hit that threshold and collect rebate money, people were using 12 watt, not necessarily as bright as the fluorescent tube, just so that they can collect the rebate money, still maintain minimum light output.
So do you see a max in the future where you don't think it ever can exceed this many lumens per watt in a LED tube?
200, 220 lumen per watt is about, I'm guessing it right now.
Okay.
Above and beyond that, it would be hard to reach without another breakthrough. Yeah.
And do you think LED tubes as a whole are more of a temporary solution, or that will inevitably become like a purpose-built LED fixture, or do you see LED tubes being around long term and always being here?
Good question. I would draw the analogy when the cable first come out. People think the movie theater will go away, right? It doesn't. And when the satellite dish network come out, they think that cable will go away. Well, it didn't. They all coexist. So my general take on the TA tube versus the TA truffer is that they will be coexist, because with the truffer, LED TA truffer or panel light, you have to remember that fixture upgrade is has to be in there for 10, 15, if not 20 years to justify the overall ROI. But with the fixture upgrade, you are then locked into whatever lumen package that original fixture will give you, say 100 lumen per watt for the next 10, 15 years. There's won't be any improvement. With AIDTA though, this BiPing is really a open interface, so that you can toss it away when it dies and get the latest and greatest and probably the cheapest 5 years, 6 years from now. Right now you're using, say, 15 watt. 5 years from now, you'll be using a 10 watt AIDTA. You get another 33% energy saving and get all the benefit you want without being logged into the 100 lumen per watt you're using today with a fixture upgrade. So there's pros and cons.
Yep.
Some of the organizations do their ROI on 5-year time period of time, so this will come out better. Well, actually, this is the 5 year. I think the fixture will looks good, but over 10 years, 20 years, the answer will be different. So different organizations come to different conclusion.
Yeah, when a lot of manufacturers come out now that have the purpose-built LED fixtures and say they're going to future-proof it, this is the most future-proof solution in my opinion, because it's like screwing in a light bulb. You can keep getting more efficient and just pop it in, easy.
Listen,
Exactly.
man, I'll tell you this. I'm gonna come out hot here, Dr. Ma.
Come on.
Okay? I don't care what anybody says. For me, the best solution is a modular LED fixture. And when I say modular, I mean replaceable components you can buy anywhere. That is an LED T8 tube, an LED T5 tube, whatever it is. If someone comes in and the claims, hey, these purpose-built fixtures are better, they're higher lumens per watt, and they're 10-year warranty, you can't fix those things. Where are you going to find the driver? Where are you going to find the LED array? All this kind of stuff. I don't buy those claims. You know what it reminds me of, Greg? It reminds me of induction.
Yeah.
You know, it reminds me of
LED and
induction.
induction.
It's like it's all the bad things about induction and LED. It's like you can't find the driver because it was manufacturer specific, the size, the shape, everything that it was. It's a different size. It doesn't fit in the box. The LED array is not compatible with some other kind of. There's too much stuff like that. I think if you don't need if you're not doing a really high end office or something like that, and you just want to save energy, go LED T8 tubes all day long, son.
Yeah, stay with the case, right? Keep it stupid and simple, and then I'm all with you.
Pop it in.
On that note, Dr. Ma, thanks for coming on the Get a Grip on Lighting podcast.
Thank you, gentlemen.
Aleddra.com, folks. That's ALEDDRA.com, the LED tube specialists, Gregor.
Yeah, and hopefully from this podcast you learned, a little bit more about the origin of the tube and where it's at now and where it might be in the future. And, we talked about before the show and after, again, it's important to point out that Aleddra really addresses all the issues that are out there with LED tubes right now in their SureFit DBA LED tube. They have safety switches built onto the tube itself, so there is no safety concern, and you can go type B. You can eliminate the ballast, which he talked about the headaches of keeping that thing, knock that thing out, do this, keep it safe, and you have a winner in Aleddra.
Dr. Moz, he laid down the challenge, to tell your sales rep from the company if he doesn't have a safety switch to touch the end of the tube when he's installing it. I like that challenge. You sent out Dr. Ma. I like it. I like your style. And so, I like the development of the LED tube I think it's going to be a fundamental part of lighting for decades to come. That LED and the fluorescent shape, it's just such a powerful, pervasive way to do things. So I really like LED tubes. It's not for not all applications, but I like it for a lot of, mid-range, low-end applications, warehouses, factories, offices. So listen to this. Thank you, Dr. Ma, for coming on the show, and go to Aleddra.com, ALEDDRA.com. And of course, Greg and I are members of the National Association of Innovative Lighting Distributors. What do you do there? You hang out and talk about light bulbs all day, son. How do you like that? Talking about light bulbs. We're going to do, what kind of LED tube do you like, Mr. Lighting Dork? I love lighting dork stuff. Let's keep talking about it. Come on down to the NAIL convention where you learn about business too. We have great speakers, and join the association that is a leader for those who sell light bulbs every single day. This has been episode 38. Thanks, Dr. Ma, and Greg Eric. Thank you.
And thank you.
Written on the rectory wall, there's a sign there for all. You are lost, Lord is there.